Question number 7. This is a bit trickily formed, and there is a simple pendulum of length 1 meter, and this is oscillating with an angular frequency of 10 radian per second. Now suddenly the support of the simple pendulum starts oscillating up and down with a small angular frequency of this. So here there are two angular frequency. Let me call this as omega, and let me denote this by omega dash. So omega dash is the angular frequency of the point of support which starts oscillating in up and down manner with an amplitude this much. We need to calculate the relative change in angular frequency of the pendulum. Alright, so this time I'll be getting omega, that's a general expression, under root of acceleration A divided by L. Let me not write G because next time the acceleration is varying. Yes, at initial instant the acceleration was G. Now I need to calculate the relative change in angular frequency, and that is 1 by 2 delta A by A. Now just think, delta A, the change in acceleration. Well, if you see the change in acceleration during the period of oscillation, what really happens is at the two extreme there would be two opposite acceleration but of large magnitude. So you can visualize that as the change part, and yes, now that will come out to be 2 omega dash square multiplied by A divided by 2 into G. So this will give us the relative change in angular frequency, and when you calculate it, it comes 10 raised to the power minus 3 radian per second. Therefore, option number 1 is the correct for this question. Time to move for the next one now. Moving forward to question number 8. This is another question from the dimensional part, and here speed, acceleration and force are considered as the fundamental units, and we need to calculate the dimension of Young's modulus in this new system of unit. Now a very regular dimensional question. So here the dimension of Young's modulus would be ml minus 1 t minus 2, because ultimately it's going to be the dimension of stress, and that's force per unit area, right? And this will be now equals to V, which is LT minus 1 raised to the power A. Acceleration, you could see that's LT minus 2 raised to the power B, and force, that's MLT minus 2 raised to the power C. That's all. So this was the new system where you need to calculate the dimensional expression of Young's modulus in terms of velocity and in terms of acceleration and in terms of force. So you calculate it, it's a very straightforward calculation by comparing the powers of MLT. Eventually you land up with option number 3. So 3 is the correct option for question number 8. Let's move to the next question, question number 9. Question number 9, it has been brought from calorimetry. So here it says, when 100 gram of liquid A at 100 degrees centigrade is added to 50 gram of liquid B at temperature 75, the temperature of the mixture becomes 90. So on the basis of this statement and principle of calorimetry, which says heat lost by one is heat gained by other, clearly liquid A is losing heat. So that comes something like this: mass into specific heat capacity of first into fall in temperature, 100 minus 90, that's 10, will be mass of the second, which is 50, specific heat capacity, that's C2, and initially it was at 75, later on becomes 90, so that is 15. That comes out to be option number 1. This has to be written as 15, yes. Alright, now we need to calculate the temperature of the mixture in the second experiment, 100 gram of liquid at 100 degree. So 100 gram of that liquid at 100 degree, so that fall in temperature is going to be 100 minus T. is added to 50 gram of liquid B at 50 degrees centigrade. So that is 50 gram of liquid B at 50 degree. So T minus of 50, that is equation number 2. Basically, it was the same two liquids but of different proportion at experiment number 1 and experiment number 2. So these are the two equations. You solve it. The value of T comes out to be 80 degrees centigrade. So option number 2 is the correct option for question number 9. Let's move to question number 10.